indirectly by letting us use this menu for free. So whenever Matt's ready, we can start this.
Thank you, Min.
Thank you.
And the privilege is mine, by the way. Thank you very much for having me. I've been in Chicago all week doing user groups like this, but this is a nice, smaller, comfortable one, so it's a good change. Thank you guys for coming out. So this is just a reminder of where we are. This is really more for my benefit than yours, but Lake County .NET Users Group, lcnug.org. You look there for announcements on the next group, I assume, the next meeting. And here's information about me, since probably you guys have no idea who I am. I'm a developer advocate for Couchbase. That's my employer. And it's my job to come to user groups like this and interact with developers on the forums and to write blogs and do tutorials and things like that. I'm on Twitter. I have my own podcast and blog. If you're interested in being on my podcast, just let me know at crosscuttingconcerns.com. I have some very cool looking acronyms there. Very, very impressive. Let's all just admire them for a second. One I didn't actually add is, I didn't have time to add this before I came out here, but as of Sunday, I am the 2016 Groves Family Cornhole Champion. So yes, thank you, thank you. But more importantly, up here, when it comes to these sessions and my job, I really like to live by that quote there. I'm not a guru who knows everything about every topic up here. I'm not an expert with all the answers. I'm just on a journey learning and talking about cool stuff just like you guys are doing. In regards to Couchbase, let's get this out of the way because, whoops, sorry, I skipped a slide. If you are on Twitter, use the hashtag Couchbase, something interesting you've learned or a picture, just so my boss knows I'm not here screwing around. I actually left my stickers on the desk when I left for the airport, so I don't have any with me, but if you want them, let me know afterwards. I'll get them mailed to you if you really like the Couchbase stickers to besmirch your pristine laptop covers. All right, let's get this out of the way, since I'm sure it'll come up, or maybe you're thinking about this, is that Couchbase is not CouchDB. They share an acronym, but they're not the same tool, it's not the same company. CouchDB is Apache Foundation, and Couchbase is Couchbase Incorporated. They share some early history. Some of the same people worked on both tools, but they're not a fork of each other or anything like that. It's just a common acronym that they share. So we're going to talk today about SQL for JSON. I'm going to demonstrate that with Couchbase, but SQL for JSON, SQL in NoSQL database is actually becoming more and more common. So we're going to talk about, this is our agenda tonight. We'll spend a little bit of time on why you should use NoSQL, and I'd love to hear from you guys, if any of you are using NoSQL, why you like it, or maybe why you haven't tried it yet. We're going to look at some basic JSON data modeling. We're going to go from relational to JSON. We'll look at how to query JSON documents. I'm going to show you some options you have for writing against Couchbase with .NET, and some of the ecosystem around data and reporting and things like that. So let's talk about NoSQL and why NoSQL. These companies here, this is just a small sample of companies that are using Couchbase in one capacity or another. And major enterprises are adopting NoSQL, and you're seeing a lot of really innovative companies on here, like eBay is up there, and we've got where's the Orbitz over here? That's a cool one. And Walmart, Tesco's fairly new. And the use of NoSQL is expanding in these companies as well. So Orbitz started using us to save their flight reservation. Was it flight reservation? It was hotel rate data. They started out using us for hotel rate data, but they're expanding to use Couchbase and NoSQL for other stuff as well. And so, the big takeaway is that companies across a wide variety of industries are starting to use NoSQL for a growing set of use cases. And so why is that? So if you're like me, you've been using relational databases pretty much your whole career. SQL databases are great. Relational databases are great. They give you a lot of functionality. It's a great set of abstractions there. You get tables, columns, data types, constraints, triggers, ACID transactions, SQL language, which we're starting to see more SQL inside NoSQL, stored procedures, and these things all come at a relatively good cost in terms of what it takes to actually start developing against them, time spent, things like that. Some databases are very expensive in terms of dollars. But the thing is, change is inevitable. And I don't think relational handles change as well as a non-relational database does. And not just change of software, but also change of hardware, change of capacity. So what if we get featured on the front page of Forbes, and all of a sudden, we have our website's down because our database can't handle all this activity. So we need to scale out our capacity. And so NoSQL databases help us solve these kinds of problems with agility, with scalability, and performance, and more importantly, availability. So let's talk about all of those. We'll start with agility here. And with NoSQL databases, typically it's easier to manage sometimes the business requirements. And by that I mean it's easier to change the structure of your data in NoSQL because there's no rigid schema for your NoSQL documents. You can store a document that has a certain list of fields, and then you can store another document that has the same fields plus one more, or the same fields minus one. Or you can store a document that contains a hierarchical structure, an array, all kinds of things with JSON. Now, that doesn't mean you should just go and put whatever you want into documents, right? So the database isn't forcing you to have a schema. In turn, you should say, well, I'm enforcing this schema. And, so you have some flexibility there, but now you have to have more responsibility as well. And scalability. So with a relational database, scaling vertically is pretty easy. You just move it to a faster processor or more RAM or a bigger hard drive, etc. But scaling, that can get very expensive. You could even hit a practical ceiling on that and say, well, we can't get a faster processor than this. Or it gets prohibitively expensive. We can get a faster processor, but it's going to cost us, $1 billion or whatever. So you have to look at more cost-effective scaling, and that typically means racking up additional sort of commodity servers and joining them together in a cluster and scaling them out horizontally. So, for example, this is an example from one of our customers actually, is Sky TV. It's a European satellite TV company, I believe. And so Couchbase does some of the work for their channel guide. When you push the guide button, you see, here's all the channels and what's on all those channels. And around Sunday at 9 o'clock, 10 o'clock? I don't know, I don't watch the show. But Game of Thrones, everyone's changing over to Game of Thrones on Sky TV. So at that point in time, they have a huge capacity problem because everyone's changing the channel at that exact time. But when the show starts, they're not changing the channel anymore. So they can now say, well, we don't need all these servers, let's scale it down. We can take 10 of them offline, for instance. We don't need that capacity. Or Black Friday, probably a better example. You might want to rack up more servers to handle traffic that weekend, but when the holiday season's over, you want to just, scale it down to just a few servers. It's cheaper, we don't need that much capacity. So you get elastic scalability there. Performance. NoSQL systems are optimized for certain access patterns, and this can give you a low response time for web and mobile user experiences. So we're talking millisecond latency. Couchbase specifically has a built-in layer of RAM to cache data. So oftentimes you're not going to disk to get documents. You're going to RAM, writing to RAM, and so it's very, very quick operations there. Availability. So when you have a distributed system like this, you no longer have a single point of failure. You have all these machines that are acting together as one cluster. If one node goes down, the other nodes can then pick up the slack and keep running. So it's still available, as opposed to a single database that's not distributed. If it goes down, well, the whole thing can go down, right? Unless you have some sort of failover strategy or backup strategy. So if the Pepsi on the left is out, you can go get Pepsi on the right instead. And if you had to do planned maintenance and upgrading, you can just take down one node at a time, do the upgrade and put it back up. You don't have to take down your whole website. You don't have to put up a maintenance page. Your site is still available to take orders and bring in revenue at all hours of the day. So when we're talking about NoSQL, it's kind of a very broad term. It doesn't have a lot of meaning to it. It's sort of a buzzword that says these are databases that are different than what we've been doing for the last 20 or 30 years. These are sort of 4 popular categories. There are other ones I haven't listed up there. Document is what we're going to talk about mostly tonight. Implementing a generally accepted subset of SQL for a flexible data model on a distributed system is something that's very hard to do. And so you don't see it on a lot of document databases. I mean, sometimes you'll see a very small subset of SQL. It looks like SQL, but it only does certain operations. Now, key value provides quick access to data for a given key. It's different than document databases. And a lot of the databases in that group provide additional functionality compared to something like memcached, which you might be familiar with, maybe not. And then we have the wide column ones down there like Cassandra and HBase. Those are kind of interesting, but also kind of complicated. And graph databases are very interesting as well. They perform a lot of interesting stuff with relationships and modeling relationships. We're not going to talk about those much tonight. Document databases can aggregate data into a hierarchical structure. So typically in a relational database, you might represent some piece of information by a table and a foreign key and another table and so on and so on. All those things might be represented in a single document as one cohesive concept instead of spread out amongst multiple tables. So that you get the flexible schema, you get the JSON data types that you've hopefully aware of already as JSON data types. We'll talk more about that if you're not. And you get some implicit relationships using JSON as well. So I want to talk about JSON now. Hopefully everybody familiar with JSON, or at least roughly comfortable with using it and what it is. It's JavaScript object notation. So let's go through a really simple use case here, some real world data. I've got a customer that I want to model in data. And I have some properties. So she has a name, she has a date of birth. Those are pretty straightforward and simple. But she also has some billing information. So she saves a Visa and a MasterCard with us. And each of those are complex. They have a number, expiration date, is this the default payment type, etc. I have connections. So I have some friends, some other customers that I'm related to somehow. I follow them, or I'm friends with them, or I'm interested in what they're buying. And purchases. So I've purchased a laptop, I've purchased a smartphone. That's in my purchase history. And these are all complex objects here that I'd also need to relate those to the customer somehow. So this is a pretty rich structure, I'd say. It's not, the most complex thing, but you get attributes like name and date of birth. You get sub-attributes, potentially, like you could split up name into first name and last name. Relationships to other data, the customers, and the products. Those could be relationships, or they could be attributes of the customer. It depends on how you want to model it. And a value evolution. So maybe we want to start out by saying you get one billing option. Maybe we want to change that in the future to say, you can have as many billing options as you want to. Or you have different types of billing options. So not just Visa and MasterCard, but also PayPal or gift cards, etc. And then some structure evolution. So maybe we can start out without connections, right? Maybe we add those later, and that's a feature we bring into the system at some point later on. We can say, okay, now we want to add this connections feature to our product. So the data gets reshaped in that way. This is kind of how you might picture it in a relational world. You break this up into at least these 5 tables, maybe some additional mapping tables for a many-to-many type situation. And in a relational database, this is going to be, it's going to be normalized. Each time you want to construct that customer object, you got to go through all those joins to bring them together. And each time you want to persist, you actually have to figure out, which table does this go into? And you have to maybe bring in an ORM to do that sort of mapping, relationships, things like that. Enforcement is via referential constraints. And again, you're using joins every time you want to have a cohesive customer. If you want to evolve their values there, You have to add additional columns, maybe even additional rows to the table. So you have to tell SQL, I want another column that says that, that has this value, has this type, things like that. Customers' contacts would be like a 1 to n relationships. You have a foreign key in there as well. So I mean, those things are pretty well afforded by SQL. We're kind of used to those issues, but evolving that structure can be problematic. We need to execute altered tables at the very least, and that may require us to take down the database for maintenance at some point, or figure out what schema to use and lock that into SQL. And that's something we have to consider when we are evolving our application. We have to maybe change that, and that can be problematic. So let's say I wanted to take this same structure and model it in a JSON document instead. How might that work? And what are some of the trade-offs there? So let's start very simple. Let's imagine a customer table with one row, and that row corresponds to one document. So I have a name field, that's Jane Smith, a date of birth, and then this document has a key of CBL 2015, which corresponds to like the primary key of that table, of that row. So that's pretty straightforward. We've got that customer becomes the document key, and the column name, column value becomes the key value pairs you see in JSON. Alternatively, we could split up the name into two subfields, like I've done here. It's a name object that has itself two fields, or I could create two fields at the root level, first name and last name. Lots of options there. You could all do that in JSON. So let's bring in another table here, the billing table. So in this case, we say this customer has a Visa card stored with us. All right? And there's a foreign key in here that corresponds to the customer ID. All right? And some other fields there. We could do that in JSON by saying, okay, there's a billing field, and it's an array, and it's an array of objects. So it could be, again, multiple types in there. Or I could start out by saying billing is just one type, and that wouldn't be an array, it would just be an object. So there's some options there as well. So it's starting to get a little more, we've gone from two tables to one document here, and that relationship between the billing methods is inherent in that document. It's implied. So if I had two of them, it would just be an array of two objects there. Now let's imagine connections. So I want this customer to be connected to some other customers for whatever reason. They're friends, or they share the same household, or whatever, right? So in Relational, I would say, okay, we now have a third table to manage connections. And it's a foreign key to the main customer and a foreign key to another customer. Or maybe it's just, that connection is its own record. I mean, whatever, however you want to imagine that. In JSON, I'd just say I have another connections property with another array of objects and have those fields in there. This connection ID could basically be a key to another document, another customer document in the NoSQL database. So kind of like a foreign key to another document. And this is the document key, so this would represent a document key for some other document. You guys follow me on that so far? Are you tracking with that? Okay, good. All right, and so this is kind of a relation via reference, is what that is there. We don't have to do it this way. We could store all the information there, but it might be a good idea if we want to keep separate documents to store that as a reference. Okay, and let's bring it all together here. We'll add in purchases. You kind of get the idea. It's the same sort of thing. Add another array of objects there. I've purchased a Mac and an iPad, and that's my purchase history. So I've gone from at least 5 tables to one document. And that JSON document represents a customer. And so the relationship between those pieces of data is now implicit in that they're all together in one single document through the use of substructures and arrays. So any questions on that so far? Does that seem like a pretty straightforward translation there? Okay, good. This is just sort of a reference slide here just to review what's going on. We get some nice benefits here with JSON. We don't have to do all those joins. There's no assembly required there. It's more flexible this way, to some extent, because we don't have to define that JSON structure. We can just pass in JSON, and we can add new fields as we feel like it, and dynamically change it, as opposed to SQL, which is a little more rigid, a little more uniform form of structure. And one of the main benefits of SQL here is that you can run a SQL query on it, which is something we've all done. We're all used to doing that. We're all good at writing SQL. You can't really do that in JSON so much until more recently, which is what I'm going to talk about today. SQL for JSON. So why SQL for JSON? A NoSQL database traditionally provides some other methods to get your data out. So a key value based set and get. You get by the key and you set by the key. You can do some script basing query APIs. So whatever the APIs the database provides for you, you can query the data. That's typically not SQL. Sometimes it might be a version of SQL, a limited declarative query. And MapReduce is something we see a lot in NoSQL. So you can write a map function and reduce function, and execute that as like a static view of your data. You'd write that in JavaScript or some other language, execute a map review, and that's sometimes that does the job, but it can make things a little complicated. And we'll see an example of that here. And it doesn't necessarily feel as natural as SQL because you're used to those joins and unions and subqueries and things like that. So let's do an example here. Let's say I wanted to find high-value customers in my systems, or my system, who have orders that sum up to a total greater than $10,000. All right? Without SQL, this is the sort of process I'd have to go through in like a NoSQL traditional database. I'd have to start by saying, okay, give me all the customers from the database. All right? And then for each one of those customers, I got to find all their orders. They might be embedded in the customer. They might be a separate document. I got to find them. And then I see, okay, for each order, give me the total amounts of that order. Maybe multiple items on that order, so I have to sum them up together. I got to sum up the grand total for all the orders. So if I have multiple orders in the system, I got to add up all those orders together. And then if I have to say, well, is it greater than $10,000? Then that's the user I want to omit. That's the user I want to count. Otherwise, I want to omit them from my results and skip them. And then I keep looping through that for each customer object. And at the very end, I sort them, put the highest one at the top. So with your NoSQL approach, you would have to maybe write a lot of this code in your application layer or in a MapReduce function. And that's a lot of work, it seems like to me, to do that, something that you're used to doing with SQL. So I think it's more natural to do that sort of thing in SQL. And that's sort of the goal of querying for JSON, is to give users, developers, and you guys a more expressive, powerful, natural way to query your data. So what we're seeing now is some convergence happening. And the SQL databases are adding JSON data types or XML data types or what have you to their database. And they're saying, okay, we're going to add some richer features to our database. And so the industry, the regular relational database industry is starting to add these sorts of things as well. So you see PostgreSQL has a really great JSON field. Really, really great, in fact. I only want to mention it, it's so great, because they're kind of a competitor. MySQL has a JSON data type. You're seeing Microsoft adding that to new SQL Server versions. And then there was an academic paper from the University of California, San Diego. They called SQL++. They wanted to solve this problem too. They wanted to write a full-featured SQL implementation for JSON, and that's the plus part, is JSON data is different than row data, so you have to add some additional functionality in there. Couchbase was trying to solve this problem around the same time, and they came across this paper from UCSD and said, hey, let's work together on this. Let's do an implementation of SQL++ in our product, and we call it NQL, N1QL, which stands for Non-First Normal Form Query Language. It's a superset of SQL. And this is sort of, I think it's the first real implementation that validates their academic paper. So it's a pretty cool project. So the way traditional SQL works is that you have some set of tables, you do a query on those, and you get a result set, which basically looks like kind of like a table, right? With NCL, you have some set of documents that you might join to other documents, and what you get is a JSON result. So kind of analogous to SQL in that way. Additionally, NCL extends the language, extends SQL to support and fully address and modify any part of the JSON document, right? So if I'm going deep into this card number field, I have to have some dot notation to say billing dot card num. Or if I have an array, I say connections 1 dot cust ID, right? So that syntax, it has to be part of this now, because I need to navigate that JSON tree. Additionally, with JSON, fields could be missing, right? So suppose I'm looking for a name field here, but because there's nothing enforced, maybe this one doesn't have a name field, right? So I have to be able to deal with a value being missing. So I need an additional way to say, is it missing, or is this the value null, or is the value a blank, empty string, that sort of thing. So here are some examples of NCL. This may seem a lot like SQL to you because it's a superset of SQL. I'm going to go into some of this stuff in more detail, but this is the sort of thing you could expect when you're working with SQL or NCL, which is SQL for JSON. Unnest in there might be a keyword you've not seen before. That's one of the newer features to deal with JSON. We'll talk about that some more. With insert, you're seeing there a JSON literal that I'm inserting with a key into a document. So I can just put the JSON right there in the query. And update looks very much like a standard update. I'm updating individual fields to certain values that fit a criteria. So here is a select statement. You can see some of that dotted sub-document reference there. So I'm selecting customers.id. I'm selecting customers.name.last name. Unnest is going to flatten an array. So I'm going to unnest this line items field, which is an array. It's kind of like a join. We'll see that in action here. I'm joining with another document using this join keyword here. I can join another set of documents that match this particular value as their key. So I can store keys as sort of a foreign key to other documents. I can do halvings and groupings and aggregations and ordering and the whole thing. I can also compose them together in subqueries. So a select from another select that is itself a union. And I can do a left join, left outer join in this case. I guess it's the same thing. Ordering, I can do paging with limit and offset. So this is a full SQL implementation. It's not a looks like SQL but only has part of it. This is the full deal. So I want to go quickly over these since really this is just SQL and you guys are used to this stuff. You can select over joins and subqueries, aggregation, min, max, sum, all that stuff you'd expect to see. Some extra cool stuff like array aggregation, which is unique to a database that has arrays in it. You can combine using union all, intersect, except. Use keys. So this is I want to select documents that have keys, A, B, and C, or has key A, that sort of thing. You can join to other documents. So if my document has a field that says customer ID ABC123, I can join to that document that has a key ABC123. So right now we support inner and left outer joins with that. Nest, which can create a JSON array in the query result. This is something that we've added because we're dealing with JSON. It's sort of a special join that embeds external child documents under their parent. And unnest is the opposite of that. It flattens out a JSON array to the same level. We'll definitely see an example of that. Join nest and unnest can be changed in any combination. So you have lots of flexibility here for writing your NCL queries. You can do lots of cool stuff. If you check out the Couchbase forums, people are always asking, how do I do this? How do I do this? And our NCL guy always has a great answer for them. I almost never see, oh, you can't do that. So let's see a quick demo of some NCL. let's switch over to duplicates. So this is, I've got Couchbase installed on this laptop here, just one node, so it's not one of those, it's a cluster, but it's a cluster of one node. So not typically practical for production, but for development it works fine. And then I've got this query tab here, which is called the Query Workbench. One of my favorite features of Couchbase, relatively new actually, but you can put your nickel up here, and the results will be displayed down there, and they are JSON results, as I said before, so you'll see them in JSON format. Let me just do a really simple one here. In Couchbase, data is divided up by buckets. So I've got this default bucket that I used yesterday for a demo. It has 3 items in it. I also have this travel sample bucket. It has about 32,000 documents in it. That comes with Couchbase as an optional data set you can play around with, kind of like Northwind with SQL Server, that sort of thing. It has some data in there that's good for the travel industry, kind of like an airport or like an airline information. So let's do a quick query here, just as a simple one to see how this works. So I'm selecting some number of fields by their name from the travel sample bucket. So that's a collection of all kinds of documents. I'm going to alias that as R. I say, give me all the documents that have a field source airport that equals SFO, San Francisco, and destination equals Miami. So I'm selecting all the routes that have Miami and San Francisco. Execute that, and there is the result in JSON. You see there's 3 results there, so it should be 3 objects that I'm returning. It's kind of hard to see on a small screen like this, but if I go to table view, maybe it gets a little better idea of what's going on here. It's still JSON, this just tool is showing it in a tabular format. So I have 3 results. Here's the first one. It's for airline 439. Here's the next one for airline 5265, and the last one, 24. So each of those routes has a source, a destination, equipment, which I guess is the airplane serial number or something, and then a schedule, which contains all the flights for that route the whole week. So day 0 is Sunday, and so there are 5 flights on Sunday, and these are the times that they leave from San Francisco. So that is it's an array of objects. You can kind of think of it as like an embedded table or a subtable. Okay, so that's pretty cool. We can work with that, use that in our app. Any questions on that so far?
How many rows do you have in the table, or in the document?
How many rows do I have in the...
Total rows, because I know you've got 3 of them.
Yeah, there are 3 rows here. How many total routes are there? Is that what you're asking? Or how many total documents are there?
How many documents?
So if I go data buckets here, I have 31,000 documents. Now they're not all routes,
Right.
but there's 31,000 total documents in that bucket.
I'm just being a little curious now. Can we change the destination to SFO itself?
You want to change to another airport?
Just SFO. I'm just being naughty.
Well, we can. I don't know if it's what's in there.
I just want to see how it will
Let's see.
give you 0 rows.
CMH, that's Columbus. That's the only code I really know. So yeah, there's nothing from San Francisco to Columbus, which is not surprising. We don't get direct flights anywhere except Chicago. So maybe I can put Chicago in there. What's Chicago's code? ORD? I don't know what exactly is in this database for sure. But oh, there we go. So there's 3 different airlines that have routes from O'Hare to Chicago. I guess that, or Columbus. I guess that would be United, and I don't know who else. I don't know if this is based on real data or not. I know we have some customers who are in the travel industry. I don't know if this is based on them or not, but there you go. Okay? All right, so that's pretty simple. That's a very, very simple NQL query there. So just want to make sure you guys are following along. We're going to make it a little more complex now. I'm going to do a join. So if you notice here, this airline ID field is airline 5209, which, okay, doesn't tell me anything. Which airline is that? Is it American? Is it United? Who is it? So we actually have another set of documents for airlines in the same bucket. So I'm going to do a join to my own bucket, to the same bucket, but I'm going to alias that as A, and I'm going to say join it to any document in this bucket that has a key corresponding to the airline ID. So if there's a document in there with a key of airline 5209, it's going to join it to that, and I can address that with this A alias. So I'll pull an a.name. Pretty, very much like a regular join in a SQL database. So execute that. I'm also ordering by the airline name, by the way. So this is American. We've also got US Airways. And, we're only down to 2 results. And why is that? Because I did an inner join. So apparently one of those airports or airlines is not in this bucket. I'm not sure if that's on purpose or not, but it helps me to demonstrate my example. Now I have all 3 results. One of the names is not there because there's no document that matches that, so it's doing a left join. So I have American Airlines and US Airways and some unknown airline. Maybe they went out of business or something. Maybe it's Frontier, who knows. Okay, so that's a join. I can join from a key in my document to another document. Pretty good with that? You guys are following along? Great. Okay, let's do an unnest now. So I have this schedule field here, which is kind of like a subtable within my document. And this might work just fine. I could probably work with this. But what if I want to flatten this out and do like a join to this table kind of? So I want to join these fields to each of these rows here. I might want to do that in some situations. So to do that, I'm going to do an unnest. I'm just going to modify this and say unnest r.schedule. So this field, I want you to unnest that into this S alias, the schedule. And then I can use that S to say, give me the flight and the time from that subtable. So this field and this field. So what do you think that would look like here when I execute this?
Look more like a regular table.
So how many results do you think I would see? I'm starting with 3 now. Would I get more, less, the same? A lot more. Execute this. And I end up with 52 results. So I'm joining all those together, and I'm flattening it out here. So each of these rows has the same destination and equipment, but they have different flight and times for each row. So here's American, and here's US Airways. And I changed it back to an inner join so we don't see that mysterious third airline in these results. So that's what an unnest is doing. It's a type of join, but it's unique to JSON data because it's a join to an array that's already in the document.
And the keyword is only specific to Couchbase. So
Say that again?
it's only a keyword for Couchbase.
Unnest?
Yeah.
I think it's unique to Couchbase among NoSQL databases. I don't know for sure because I don't know all the NoSQL databases out there. But it's definitely unique to JSON for sure. I mean that wouldn't really, you couldn't really do that in a SQL database, I don't think. Yeah, go ahead.
How about basically a reference? It's basically a document that contains references to other documents.
Yes.
So specifically array of pointers.
Yes.
Basically, other documents.
You're asking if that can be done?
It's a different bucket.
You're asking it, in a different bucket?
Yes.
Okay, you can definitely join between buckets in Couchbase. So I'm just for simplicity, I'm doing it within the same bucket, but I could have travel sample 2 or hotel data. I could join to that.
Okay.
Sure. Right. And certainly you could join on multiple keys. So I'm joining on one key here, but I could join to if I had an array of airlines, for instance, I could join to that. Yeah.
Document, is there like any type? This bucket, we have several types of documents, right?
Is there types of documents in this bucket? So The answer is there are different types of documents, but only because the way I've defined the data. There's nothing that's on Couchbase that says this document is of type X. So Couchbase doesn't enforce anything like that.
What if the keys, like in this case, you're joining all the keys, right?
Yes.
Let's say it has the same key, two different types of documents.
Okay, so that's a good point. I guess I didn't mention that. Within a bucket, you can't have two documents with the same key. They have to be unique keys within that bucket. So yeah, very good point.
Another way to say that would be that a lot of documents may have similar schemas rather than document types.
Yeah, yes, they would have similar schemas in the sense that you define them that way,
Right.
but Couchbase doesn't enforce them. Yes, that's a very good point. Yeah, so in this travel sample, for instance, there's probably 6 different types of documents, like a route, an airline. There's landmarks, I think, are in there too, and things like that. They're different because they have different fields in them. But there's nothing that I can do to Couchbase to say, oh, separate these documents out into different types. At least not yet. It might be a future feature. But there's nothing about that right now.
Would it be accurate to say a data bucket is nothing more like approximately like a database?
Yeah, I think that's a pretty good, we'd say a good rule of thumb is 1 bucket per application. That's a rule of thumb. That's not a hard and fast rule, but that's about right, yeah. Yeah. Okay, let's get a little more advanced here. So now I'm going to say, sorry?
Sorry to interrupt.
That's
And
okay.
As far as joining on x dot y or whatever, there's no data types here. So you can basically compare only as strings, right?
Well, JSON does have some types. You have number and you have string, and let's see, you have null, and then Boolean. Those are your 4 JSON data types. You also have array and object. So yeah,
An
go ahead.
object.
Yeah, yes, and object, yes.
So right now the airline ID, what is that?
Airline ID is an integer. And if I show you in JSON view, it'd probably be more obvious. Right here. Airline ID, oh, it's not obvious, is it? Let me bring up the other query. Actually, that's probably a string, right? Because it has the word airline in it. Let's see. Is that the wrong one? This one right here. I should be using my history button, but yeah, right here. So this is a string. You can see in JSON it's represented with quotation marks. Right here, this is an integer because it's just a.
And if I try to
Just a
compare
literal.
a string to a number, will Couchbase give me an error? Or
So I don't think you get a type mismatch error. It would probably do its best to compare them to one another. Yeah. No, that's okay. That's a good question. We could try it later if we have time. The last thing I want to show is, I just want to narrow this down. I'm adding this and here. I'm saying give me all the flights on this route for day 0, which is Sunday, I guess, in the travel industry. And this would return a smaller list. So these are all the flights on Sunday from San Francisco to Miami. So there's all 9 of them. It might be a useful thing to display to your user that's interested in booking a flight. You could probably narrow it down further by time. Okay? Yeah, go ahead.
Do you lose a lot of the performance of using the NoSQL database by implementing a SQL query language? So I'm always imagining NoSQL to be something where you're always going to say, hey, give me this document, I want to use this to present a result to the
Yeah.
user. If you're going to overlay a SQL query language, then are you going to have a query plan and indexes, and how do you?
Yeah.
And at some point, then does this still really feel more like SQL and less like a NoSQL
So
database?
a lot of questions here. Let's see if I can get them sort of one at a time. So your question is, how does the performance of this compare to, like, just getting it by key?
Well,
Getting
I'm
a document by
stored
key?
just by getting it by key.
Yes. Yeah, definitely.
So is it still practical? Or do you still have those advantages of using a NoSQL database?
So you can use either one, whichever one is more. I mean, if you're doing something very, very simple, just getting a document one at a time, there's no reason to use Nickel
And
for that.
that's right, you're just going to
Yeah,
get the key.
you just get it by the key.
Yeah.
If you have something more complex, like what I'm showing here, where you want to join to another document and you want to do some aggregations and calculations, you could go through the MapReduce route. You could go and grab all those documents like I was showing earlier with that flow chart. You could do that, I think it's more work
Yeah.
to do that.
I agree.
There may be some performance benefit to it, but there's a lot of extra coding time for that. So you got to balance that. So
Then I guess the other part of the question is how does this make fast?
yeah, so indexing is very important. There's a very rich indexing library or set of types of indexes you can use. The travel sample comes with, I don't know, 10 or so built-in indexes. And there's 7 or 8 different types of indexes. I don't want to go into all of them tonight, but Couchbase can do all those. And indexing, you also have the same data notation because you can index by embedded objects or objects in an array, things like that. Indexing is probably even more important for Couchbase because we have that one bucket that contains documents of all kinds. Whereas opposed to SQL, you have, you're indexing a single table. In Couchbase, you're indexing a whole bucket. So it's very important to get good indexes for good performance. You can have what's called a primary index, like I've got up here on default, right here, and that's just going to index every document by their document key, I believe. But if you run a query and it hits that index, it's basically like a table scan, right? It's going to be slower than if you have an index defined. So, for instance, on here I've got source airport has got a index on it, so that makes my queries faster. Or if I wanted to do it by type, the type field, say type equals airport, it's going to hit that index, it's going to be much faster. And actually, if you go to query, I hope I'm not getting too off track here, but if I type in the keyword explain, execute, it'll tell me which index it's actually using in that query. So I can know if I'm hitting an index or if I'm hitting the primary scan. So in this case, it's hitting the def source airport index, which is why it's going relatively quickly and not scanning the entire bucket. Okay. All right, I think that's all the NoSQL examples I have for now. Back over here to the slides. I'm going to try to get you guys out of here in time for the train or whatever. So here's just a summary of some of the stuff you can do with NoSQL. Don't want to go into every single thing. One thing to point out is, this is pretty cool here. If you have an array, you may want to match, does this array have anything that matches this? Or does everything in that array match it? So you have this sort of any and every syntax that you might want to apply. If a field name is missing, so it's just not in the JSON, that's something you might need to know. Say, well, is the name missing from that document? Well, give me all those documents that don't have a name field. And we already talked about some of the traversal stuff. You can construct JSON dynamically. Let's see. Data types, we already talked about these. The top 4, I mean, you have equivalents in SQL, but arrays and objects, something you get in JSON data. They're not in traditional SQL. You also have some sort of non-JSON data types that Couchbase can handle as well. Missing, we talked about that already. You can also store binary data in Couchbase. You're going to lose some NoSQL functionality there because you can't really, you can't really look at a binary and say where something in this binary is something. This doesn't really make a lot of sense. But it is. You can query with NoSQL in binary, but you lose some functionality there. We also add some data type handling into Couchbase or into NoSQL. There's no date type in JSON, right? Famously, unfortunately. But we have some functions to help deal with Unix timestamps and to display string versions of timestamps, things like that. We have some well-defined semantics for order by, comparison operators. They're all defined in there. You can select a string as an integer. So that's kind of to your point earlier, to convert data over. You can modify data with NoSQL, so updates, deletes, inserts, merges, they're all there in NoSQL, the whole functionality. One thing to note about NoSQL and NoSQL in general really is that you don't have the same concept of transactions as you do in a relational database. So if I were to execute an update that updates, say, that would update 10 documents, and the 8th document, it fails for some reason, those first 7 would still happen. So it's not an all or nothing, it's incremental. So it'll execute all the ones it can, and when it fails, it'll cut out right there. So that's a main difference between a lot of NoSQL databases and relational databases, is that there are no sort of batch transactions, at least not yet. There is per document atomicity though. Here's some more examples of data modification. So it's just JSON in, JSON out, update, delete. I don't know why we have these weird names on these fields. This must be left over from the UC++ examples or the SQL++ examples. But there's some raw JSON data up there. Indexing, which we touched on already. You can create indexes, you can drop them, you can explain them. If you want to know more about indexes, this article covers them all in great detail. Check that out. Lots of cool indexing stuff on there. I don't have time to go into it tonight. You can have functional indexes on any data expression and partial indexes. All kinds of cool stuff in there. Here's a quick index overview. So say I have a customer over here. I could create an index on just their card number. Maybe that's tied to the postal code for some reason. So I'm indexing this dotted notation in here. That's important when you're dealing with JSON. I can also do another one with the expiration dates. Ordering is important when indexing, just like it is in a lot of relational databases. And this is definitely useful for speeding up the queries. If you have large set of documents, it's absolutely vital that you have good indexes. So let's revisit our example that we looked at with the, oh, did I spoil the surprise? I did, darn it. Here's our flowchart from earlier. I'd have to write code for this, maybe map reduce queries, combine them with application code. I could replace all that with a nice, natural looking SQL query that does the summation for me, does the aggregation, does the ordering. I think I'd rather write that than write all that code on the top. So I'm leveraging my existing SQL skills to do this, to use a NoSQL database.
When you create an index, where does it reside? Is it in a separate file?
So the indexes are not stored in documents, if that's what you're asking.
That's what you got.
Right, they're stored in, I don't know, some index place in Couchbase.
Index place.
Yeah, there's an indexing service. I didn't go into the Couchbase architecture too much. There's an indexing service that you can deploy to one or more of your nodes. It's probably stored in there. It might also be stored alongside the data. I'm not exactly sure.
But it's not memory only.
Correct. Yeah, it's not memory only. It's persisted to disk. Yeah, absolutely. You had no question? Yeah, sorry.
So, I'm a little new to some of this stuff.
Okay.
Not the SQL stuff, but doing this, like you had said it here at the top.
Yeah.
So how does it? So where does this SQL now get executed on the server, and then returned to the client, or is there like a middleware in between there, or a library you're using on the client? Like,
So the question is, where is this SQL or this NoSQL executed? It's executed on the Couchbase server cluster. There's a query service out there that will analyze this, execute a query plan, or come up with a query plan and execute the query plan and return the results to you. So there's no middleware or anything like that. It's all running on the Couchbase server. Okay. Here is a quick summary of SQL side by side with NoSQL. So no type mismatch errors, well, not as many anyway, as we mentioned earlier. Get fully addressable JSON, which regular SQL can't do. Well, at least, yeah, I'd say regular SQL can't do. And then you get the flexible document structure. Okay, let's go on to, we're running out of time here, so I'm going to go on to .NET APIs. So if you guys are all .NET developers, I assume, or at least familiar with .NET, there is an ODBC driver you can use to access Couchbase. It's provided by a company called Simba, and you can use this to hook it up to existing reporting applications like Excel or Power BI or Crystal reports. So you can execute reports against Couchbase using Simba. It's based on ODBC standards, so you're writing ANSI SQL. Well, you're not writing ANSI SQL. Yeah, you are. You're writing ANSI SQL. Simba is taking that, translating it into NoSQL, and running that on Couchbase and returning the results. 32-bit, 64-bit, and yeah. So a little ODBC. There's also a JDBC driver as well, if any of you guys are doing that. Here's an example of .NET code using the ODBC driver. I wouldn't recommend you use this in .NET unless you have a really good reason to. I just set up a DSN, And then I'm passing, this is not NCL here, this is ANSI SQL. I'm executing that against the reader and looping through it. I'm just writing out the, I guess it would be the, I don't know, route name or something. Okay, so you can use.
No REST API?
What's that?
No REST API?
This is a REST API?
Do you have a REST API?
Yes, there is a REST API for Couchbase. In fact, NCL uses the REST API. Also, if you're using ODBC, you can also, if you want to, I'm not sure why, you can say use NCL mode. So it's not going to translate the ANSI SQL, it's going to use the NCL directly. Again, I don't know why you'd want to do this, but you can. Maybe if you're writing a report application or something. Here's how you probably should do it. Use the .NET SDK that Couchbase provides, and you can just say query request.create, pass in a NCL string there. So this is actually NCL. And then you can say buckets, which is an object you get with the SDK. Query, map the results to types of person. Here's the query, and they get the rows from that result. And you have a list of person objects that correspond to your documents. You also can get parameter passing because, yes, you can have SQL injection in a NoSQL database. Also supports asynchronous, which I'm not showing here, but you just do .query async instead. Link to Couchbase is available, so if you guys like Link, like me, it's an open source project out there. It's not officially supported by Couchbase yet, but a lot of the Couchbase people work on it. And you can do things like this. Say query by person, order by, do a select, do a where, all that sort of stuff. It'll generate the NCL for you. It's very cool. With Simba, you get access to these tools like this. You can hook them right up to Couchbase, Tableau, Power BI. I don't know what the other ones are up there. I'm not really into that sort of stuff. We also have some integrations with other big data type tools like Kafka and Spark. Those don't use ODBC. They use our own native protocols, which are called DCP and XDCR. So you don't have to go through the whole Rube Goldberg thing to get to that data. You can use a direct integration. Here's an example, and I suffered for this art here, so please enjoy responsibly. I fired up Excel, and I connected it to an ODBC, the ODBC driver, and queried against the travel sample bucket. And you can see it's still calling it tables and columns because it's Excel, but I can start querying data into Excel. And this one especially pained me because I spent many days early in my career writing this type of stuff in Excel and Access. But if you're familiar, this is the query builder you get in Excel or Access. Yeah, look, I'm with you. But you can, create your SQL there, and if you hit this SQL button here, you'll get the ANSI SQL behind the scenes. Oh. Okay. More fun is actually this online interactive NCL tutorial. So you don't need to install Couchbase to play with NCL. You just go to this website, and it's interactive, so you can type in your own queries. I don't think everything's enabled for security reasons. Like you can't do an update or delete. We're just not going to allow it. But you can do a lot of selects and stuff like that. That's a lot of fun. I just tried that today. It's really cool. It might be a little bit old, actually, because we're coming up on 4.5 now, so this might not show some of the new features, but still fun to play with. I wish I had these stickers to give you guys. They're just sitting on my desk. I can picture them right now. I didn't put them in my backpack. But if you really want one, any of these look cool to you, come talk to me. I will write down your address, and I will get you those stickers, I promise. If you're interested in a deeper dive into Couchbase, there is an event coming up in Schaumburg, which I assume you guys know where that is. I have no idea. September 22nd. It's a free event all day. And here is a shorter URL. If you don't want to write down this long one, you can go to that CB Day Chicago and sign up for that event. I won't be there, but I know at least my friend Remus from this area will be there, and some other Couchbase people talking about a deeper dive into Couchbase if you're interested. I'm part of the developer advocate team. You can find information that we're putting out on blog.couchbase.com or the developer portal. Follow us on Twitter, #Couchbase. We're always watching for interesting stuff on #Couchbase. We're looking at Stack Overflow a lot. If you have NCL questions, like really deep NCL questions, the place to go is forums.couchbase.com. There's a whole forum just dedicated to nickel. I'm M. Groves on Twitter, and I think I'm done before 8 o'clock. Oh, 1 minute till 8. Okay. So if you guys need to go get a train or whatever, but I'll be here as long as it takes to answer questions and talk to you guys. So thank you very much.
Where'd you come in from?
I live in Columbus, Ohio.
That news didn't travel all the way to the back of the room.
What's that?
A long way.
Yeah. Go Buckeyes. It's required by law. I'm sorry.